Hello, in this video, we will present more examples for understanding Bayes' formula. So we know this is the Bayes' formula. So if we look at the left side, this is called posterior probability, because we want to know the probability of event BI, but given A is occurred. So this is the posterior, because this information for occurrence of A will update our prior probability of BI. So this is the prior probability, and this is the conditional probability of A given BI. So BI, BJ, we can think of as different cases of one event. So for example, if he is a man or if he is a woman, like this. So this is the different case of one event. So if we want to know this one of the case probability given A occurred, so we have to calculate odd probability for each case for the prior probability times their conditional probability of A given this case. Then this is called total probability in the denominator. And on the numerator is one case of this probability which we want to know in the posterior. Then times its conditional probability of A given this case occurred. So we show an example. So you answer questions in the test. A student can either know the answer or not know the answer. So if she does not know this answer, she may guess the answer. But in both cases, she may have the result correct, right? So if she knows the answer, she will get the perfect result. 100% she knows the result. Then if she does not know the result she guesses, she also has a probability to get the correct answer. So here we know the probability that she knows the answer is P, and 1 minus P is the probability that she does not know the answer and will guess the answer. Then in these two cases, if she knows the answer, then she will get 100% correct for this answer. And if she guesses the answer, she also has probability is 1 of M. Here M is the multi-choice alternatives. So now the question is, what is the conditional probability that a student knows the answer to a question, given that she answered it correctly? So this is the posterior probability of that she knows the answer, right? Because we know here she gets the answer correctly. Then we will back to think what is the real probability that this student knew the answer. So here P and 1 minus P is the prior probability. If we do not know whether she answered the question correct or not. But now we know that she answered the question correct. Then we will update this information and will calculate the conditional probability that she knew the answer, given this answer is correct answer, right? So we let C and K denote the event that student answers the question correctly and the event that she actually knew the answer. So C means correct and K means no. So now we want to calculate the probability of K given C, right? Because we want to know the probability that she knew the answer given she answered the question correct, right? So this is the posterior probability of K given C, right? So if we look at previous pages, Bayes' formula, then probability of C will be in the denominate. So this is the total probability of correct answer, correctly answered, right? Then in the numerator is the probability of K times probability of C given K, right? So this one. So this one is in the numerator, and probability of K prior probability of she know this answer times the probability of she will correctly answer the question if she knew this answer. So this one is P in our problem, and this one is a 1, right? This conditional probability is a 1 because if she knew the answer, she will answer question correctly 100%. So this part in the numerator will be P, right? And we want to calculate denominator, which is the total probability. So this combines in two parts. The first is she knew the answer and she correctly answered the question given she knew this answer. These two multiplication. And other case is she does not know the answer. She guessed the answer and the probability of correctly answered given she do not know the answer. So the first part we have calculated in the previous page is P, and the second part is 1 minus P times 1 of M, right? If she does not know the answer, the probability is 1 minus P in the information given. Then the conditional probability she will answer the question correctly if she guesses this answer is 1 of M. So this is the total probability which will be in denominator of Bayes' formula. So now it is easier that we will divide this two parts and we'll get the probability of she knew this answer given she answered the question correctly is this result. So say if M is 5 and this person has 50% of the probability she knows this answer, and other 50% the case she does not know the answer will guess this answer. So if we fill these two values, then the probability of she actually knew this answer given she correctly answered the question is 5 of 6. So we can see this is posterior probability of she knew this answer after we get information or the result that she correctly answered the question. So this is the posterior probability 5 of 6, which is larger than this prior probability. So this is updated given that she answered the question correctly. So now if we think another case, if she does not answer the question correctly, if she answered the question wrong, so what is the probability of she know this answer given not correct in the result, right? We can also calculate such kind of posterior probability. Thanks for watching. And we also has a website for Python and Arduino if you are interested.